This is going to be Chapter 6, Math for Medications, and this is going to be Part 2, which, after completion of the slide set, you should be able to utilize a 6-formula sheet to calculate medication math, understand what volume delivered means, a dilution, a weight-dependent dose, dose per minute, and volume over time, both hour and minute. So topics we're going to talk about: volume delivered, dilution, weight-dependent dosing, dosing per minute, volume over time, and that would be like a certain amount of volume over hours and a certain amount of volume over minutes. So volume delivered. This formula is used when you need to administer a specific ordered dose of medication. So very simply, what we have on hand is always placed over here. So the example here is 100 milligrams in 5 mils. And then here is where we place how much we want to give. And then we do something called cross multiply. So we're going to take 5 times 75 and 100, and this x is 1. So we'll get 375 over 100, and this is one of those problems where it has 3 zeros. Well, the decimal point is here and here, but if we move it in to where it's 2 spaces in, we can do this one the same. 3.75 mils. So another example here. The ordered dose of 25 milligrams of lidocaine. How many mils to administer 25 milligrams of lidocaine? So we have on hand 100 milligrams of lidocaine and 5 mils. And we want to administer 25 milligrams. And I don't know how many mils. That's what we're looking to do here. So 5 times 25 is 125. 100 times 1 is 100. And we can still do that same little trick, both top and bottom. 1.25 milliliters would be our answer. That was an example of volume delivered. Dilution. This formula is used when you're making your own medication drip. So if you had a custom drip, an example of this would be like a custom epinephrine drip, then by using the concentrated version of it, you could easily mix your own dilutions. You have to have a few known facts though. Either you need to know, 1, how much drug you have on hand, then you can figure out how much fluid you would have to put it into, or figure out what the concentration strength that you want is, the new concentration strength, and kind of work the math backwards. Or off of the formulary or your drug protocols, look at what, if an example of this would be lidocaine drip. If we wanted a lidocaine drip mixed to 4 milligrams per milliliter, then that would be our starting point. So the rest of the math, knowing what we had on hand, we would figure backwards. And I'm going to show you how to do that here in the next slide. Alright, so this is an example of dilution. Yeah, let's go back one. Let's go back to this previous slide and let's work one out here really quick. So this is an epi drip. Let's just work this one that we have pictures of. This is an epi drip, and this is a 1,000 milliliter bag. And on these whole dilution things, the mils always goes on the bottom. So we have 1,000 milliliters. We don't know how many mils, but let's use their figures. We want it mixed to 1 microgram per milliliter. So this is one of those formulas where if you have the bottom number, you're going to multiply your answer. So 1,000 times 1 is 1,000. So we're going to put 1,000 mics into that 1,000 milliliter bag. Same way with the top. If we had only the top number, we knew how many micrograms we actually had, which this is the same answer in this case. Then we would divide by our concentration strength to get our bottom number. It'll make more sense on the next slide. I'll show you here. So in this case here, we have a 250 milliliter bag. And I would like a concentration strength to 4 micrograms per milliliter. So, using this formula, dilution, if we have the bottom number, or the amount of milliliters, we're going to multiply our answer by that. 250 times 4 is 1,000. So we need to place 1,000 micrograms into this 250 ml bag to yield a concentration strength of 4 mics per mil. And we can test that out here really quick by taking these zeros away here. 100 divided by 25 is 4. Now, the last part of this, since we figured this with micrograms, the answer that we get will be in micrograms. This is in milligrams. So this is where that conversion factor comes in, and y'all are going to have to get this to where you're doing it naturally. That in 1 milligram, there is 1,000 micrograms. So in all actuality, I need this whole 1-to-1 1,000 concentration strength in this 250 bag to yield this concentration. Weight-dependent dose. Now this is something that's probably easiest run on a calculator. An example of this is going to be with dopamine. And we're always going to do dose. And since this is weight-dependent, times the weight in kilograms, times the drop factor, divided by the concentration strength of our drip. Now this drip's concentration strength is at 1,600 mics per mil. So if you want to do this on your actual calculator, this is 5 times, put 100 kilogram patient. So we'll start them off at 5 mics, 5 times 100 times a 60 drop set, divided by 1,600. And it should come out at 18.75. Every time that your dosing goes up from this, let's say it went up 7.5, you would need to refigure 7.5 times 100 times 60 divided by 1,600. Very easy, simple formula. Okay, so example of this. Let's do, we want the patient running at 7.5 mics per kilogram per minute. So we would run this out here really quick. 7.5 times 100 kilogram patient with our drip set, which is 60, divided by the concentration strength here, which is 1,600. And this is going to come out to 28 drops per minute. If you don't believe me, plug it in the calculator really quick. You should come up with 750 here times 60 and then divide that by 1,600. Alright. This is a clock method, or an adjusted clock method, for determining a weight-dependent dose. But the thing is, on a clock method, is you have to know what the values are in your concentration strength. So I'm going to give you a brief overview of this here really quick. So numbers, I'm going to show you how I got to these numbers as well. So we take 1,600, and that's our normal concentration strength for single strength dopamine. This would be dopamine. 1,600, and we're going to divide that by 60. Now, what that's doing, what that's given us, and I'm going to kind of put the answer down here, 1600 divided by 60 is going to give us 26.666 ... This is going to go on for a while. So what we've just figured is how many micrograms are in each drop of our actual IV drip set. 26.666. Now there is no way you can figure 26.6666666 in your head. So let's consider that each drop, one drop of this 1600 mics per mil is equal to 25 micrograms per drop. Now we know that 60 drops is 1 mil, and 1 milliliter of this is 1600, and we would know that 0 drops of it would give us 0 medication. In the middle, 30 drops of it would give us 800. That would mean that 15 drops would give us 400. That also means that 45 drops is going to give us 1200. So now that we've made this a linear clock, if you will, and we know that each drop is equal to 25 micrograms, let's refigure that first problem that we had. We want to start the patient at 5 mics per kilogram per minute. So at 5 mics, and the patient weighed 100 kilograms, 5 times 100 is 500. Now, where 500 is somewhere about right here. 15 is the closest. But we are 100 short between a number that we definitely know, which is 400, and a number that we need, which is 500. So the question is how many quarters are in a dollar? And there are 4. So 15 plus 4 is 19. That's how many drops per minute we should be administering to our patient. Alright, this is going to be dose per minute. And in dose per minute formula is used when you are continually delivering medication, and the dosage is given in milligrams or micrograms per minute. The formula itself is this right here. So dose times whatever drip chamber and the drip factor that you're using, and this is divided by the concentration strength. Now there is alternate ways of doing this, and I'm going to show you right after I get through doing this. It's called the clock method. So we'll kind of verify whenever we're doing this one, practice together. So dose times drip factor divided by concentration strength is this formula. An example, let's say that we had a drug that was 4 milligrams per milliliter, and we would like to give them 2 milligrams per minute. So 2 milligrams per minute dose times the drip chamber. Let's say that we were using a 60 drop set, and that would be all the information we required for dose per minute. So 2 times 60 is 120, and then 4, we would divide this by 4. So 120 divided by 4 is 30, and that's already in drops per minute. And once you figure out these formulas and put them in your head, they're very easy to apply. So any time that you would need a specific dose per minute in a continuous drip, this is the formula that you would be using. So again, one more time to review before we do it. Dose times the drip chamber divided by the concentration strength of the drug. And that's going to equal drops per minute for you. Alright, let's do one. Let me explain the clock method before we get too far into this. The clock method is a way of kind of doing the same thing we did in that linear model, whenever we're looking at the dopamine, 0 drops equals 0 amount of medication. Well, in this clock method, if we have 4 milligrams in 1 milliliter, then that would mean that 4 milligrams is going to be essentially 60 drops. If we have a 60 drop set, that would mean that 2 milligrams would be 30, 1 milligram would be 15, and 3 milligrams would be 45. So if we had something, let's just keep the clock up here, and that's the same thing that this is, that 1 milligram, this is why it's called the clock method, 1 milligram would be 15 minutes or 15 drops. 2 milligrams would be 30. 3 milligrams would be 45, and 4 milligrams would be 60. Alright. So, with this drug over here, the concentration strength of 4 milligrams per milliliter, I would like you to administer 3 milligrams per minute. So 3 times 60 divided by 4. So 3 times 60 is 180. And if we divide that by 4, we are going to get 45. So I'll show you. 180 divided by 4. 4 times 4, 16, 2, 0, 5, 20, 0. So 45 is our answer. 45 drops per minute. Volume over time. We're going to look at 2 different formula sets here. First formula set is going to be volume over time in hours. A lot of people say that that's a lot easier than the volume over time over minutes, but I think they're both equally the same. So the first one we're going to look like is in hours. And we need to place how many minutes there are in an hour. So this is probably the most complicated part of it here. So let's say that we had 2,000 milliliters that we wanted to go in over 4 hours. Well, we have to put this in play. So we have a 60 drop set, and we need to know how, since we did this in hours, we need to know how many minutes are in an hour. Now this nicely crosses out and makes 1 over 1. Now we can reduce this nice and easily. I'm going to erase some of this so that everybody can see here. So this 60 and this 60 here crossed out, and it's 1 over 1. So 2,000 times 1 is 2,000. 4 times 1 is 4. Now the reason that we do this, if we did not have a 60 drop set, and we had a 15 drop set, we could still figure the formula, but we would still have to put 15 over 60 in here to get our answer that would be appropriately for that drip set. So in this case here, 2,000 divided by 4 is going to be 500. And these are pretty easy to do. So let's say that the doctor ordered 4 of these, what we see right here, which is 1 liter bags or 1,000 milliliters. He ordered 4 of these over 6 hours. And we were using a 60 drop set. 4,000 milliliters over 6 hours times 60 drop set, and then there are 60 minutes in an hour. Now these cross out to where there's 1 over 1, so we're going to figure up and reduce 4,000 divided by 6. And if we need to do this a long way, six, 4, 0, 6 times 6. This is going to be point something. So 666 is probably what we're going to look at here. But 6 times 6 is 36. We'll have 4, 46. We'll have 4 left over. Make another 0, 6. So I'll just figure it out to that one. 666.6. So 667 drops per minute. And this is something that we know here that we learned in the last slide set. If we're using a 60 drop set, drops per minute and milliliters per hour mean the exact same number. So this would also, if we're setting it on the pump, be 667 mils per hour. Volume over time minutes. This formula is used when you're delivering a specific amount of fluid and a specific amount of drug diluted in that fluid, and the drug is to be delivered over however many minutes, or X amount of minutes. So how we do that is the amount of fluid we need to be infused, say 50 mils, and we place our drip factor in here. This is using a 60 drop set. And then down here we place the amount of minutes that we actually needed to go in over. So this was 50 milliliters over 10 minutes using a 60 drop set. So how we would do this is straight multiply across. And I reduced. It was easier to reduce it here. So 10 will go into 10 one time. 10 will go into 60 6 times. So 50 times 6 is 300. And 1 times is just 1. So 300 divided by 1 is 300 mils per hour, or 300 drops per minute. So let's figure one together here really quick. So I would like this diltiazem, or cardiazem, for you to mix this into 30 mils. You have a 60 drop set. And I would like this to go in over 5 minutes at a minimum. So looking at this, we can reduce it a little bit. 5 will go into 5 one time, 5 will go into 30 6 times. 6 times 60 is 360 over 1. 360 drops per minute, or mils per hour, since we used a 60 drop set. Pretty straightforward, huh? In conclusion, by understanding the formulas for medication math, the concept of rapid medication calculation is achievable. References for this slide set were taken from Beck Pharmacology for MS Providers, Delmar Learning, pages 58 through 70, and Bledsoe's Pre-Hospital Emergency Pharmacology, 7th edition. Graphics in slide 4, 6 and 7, 8, 12, 15, and 17 were taken from various drug company sites listed there, mostly drugs.com. If you have any questions concerning this chapter, feel free to give me a contact. My name is Roy Smith. I can be reached at smithr@emsa.net or 45219-7613. Thank you.